to the last day. We've got a clear disk up here for the next few days, and then the coronal holes will reinvade lower latitudes. The solar wind endured a drawn-out rise into a coronal hole stream over the last 2 days. Earth's field had plenty of time to adjust, and geomagnetism is quiet. So let's revisit that bonanza of filament eruptions we showed yesterday. It is clear that the bulk of these CMEs would miss Earth, but that's about all we could say without coronagraph updates. This morning, we can easily see the bulk of those CMEs missing Earth off to the sides, but also there's a faint halo signature with the last one, and it's not surprising that NASA's Enlil spiral shows a minor impact coming to Earth on the 17th. But right before that, NOAA is tracking the leading edge of the next coronal hole, and they think it will arrive the night of the 16th. Most likely scenario is that those two merge, but if they hit in succession, the chances for low to mid-range geomagnetic storms does increase. Quick note as the top quake of the day was a blot echo at the deep transitions beneath Japan. When we look and find atmospheric signals nearby with the large storm, that's 2 of the major earthquake watch factors rolled together there. Let's move on to the top science news and get started with some aesthetics. Folks, the most detailed universe simulation is now online and available to everyone. The 4D2U project comes out of the NAOJ and allows for a gorgeous fly through the cosmos as it is envisioned with dark matter, dark energy, and everything else they can't see or characterize. It's fun to watch though, I'll give them that. Up next, it's always fun when scientists pay half attention to what's going on. Here, they're scoping hot gas and plasma near the nucleus of the Milky Way. They're also getting the surrounding cooler gas, and they are identifying a number of regions that are dense enough to form stars. But for some reason, they're just not. They offer some basic guesses, but in the end, say it's a mystery, and perhaps they should simply turn around and look into the past another way. Take what you learned from the baby stars you have found in there, and figure out what they've got that the starless regions don't. While we're out here in space, let's take a swipe at sterile neutrinos. As WIMPs die as dark matter candidates, axions are on deck and having no less grand a failure, but sterile neutrinos are many astronomers' vote next in line. Sadly, that's a bit of pet project bias there, as there really isn't the slightest bit of evidence throughout the search history to back that pony. We're jerking the wheel back to Earth here for a very interesting paper that would fully explain why some foreshock and aftershock patterns vary so greatly, from no foreshocks to no aftershocks and the sliding scale between. If you've ever wondered why that is, and have a whole bunch of time to read complex geophysics, I recommend this one. Let's ease back out into space with another nova-like variable, and this one apparently is changing its orbital period. Veteran observers smiling at the nova-like description Easter egg. Please, astronomers, just call it a nova. And speaking of, folks, we have long described the stellar atmosphere accumulation nova, and this last week we went over the deflagration aspect rather than a nuclear explosion. Well, that's not just a paradigm for the smaller recurrent nova, the dwarf nova, and the long-period solar micronova. This interaction with a dense circumstellar medium can trigger the biggest nova events in the universe as well. Dense circumstellar medium is the cute academic way of saying that space gunk clogged the outward pressure of light and stellar wind, leading to heat, plasma interactions, deflagration, and boom. We greatly appreciate your support. We've got wind maps and